Hello friends, welcome back to our channel Geological. Today in this video I am going to talk about the numericals for GATE Geology, and these numericals whatever I will discuss, they are asked in the previous year exams, and also they are most frequently asked numericals. So based on those formulas, questions can be asked in a little bit different format, but the basic concept will be the same. So let us see the first question. This is based on the partial melting, and many times 2-3 papers have these type of questions related to the partial melting. Let us see what it is asking. A source rock undergoes melting assuming the batch melting of 5%. Now there are two models of melting. The first one is your batch melting, then equilibrium or the fractional melting. Okay, so these two different melting with the different formulas. It is asking about the batch melting. So 5% batch melting, 5% partial melting have been done, and the bulk distribution coefficient is 0.045, and we have to calculate the enrichment factor. Okay, so here the formula is concentration of element in liquid to the concentration in original is equal to the 1 upon di 1 minus f plus f. Sorry, my writing is not good with mouse, but I am trying it to be understandable. Okay, so this is the formula for batch melting. Okay, where di is the bulk distribution coefficient, which is 0.045, and f is the fraction weight fraction of melt which is produced. So how f will be calculated? 5% partial melting, so it will be 5 divided by 100, and the value of f will be 0.05. Okay, so now we have the value of di, we have the value of f. We can calculate this concentration of in liquid to the concentration in origin. Okay, and this is also known as your enrichment factor. I hope you will understand it and you can calculate it. I am leaving the calculation for you. In sometimes what they ask, they will give you the concentration in origin source rock, and they will ask you about the concentration of liquid. So same formula will be used. Sometimes they will give you the concentration in liquid and you have to find out the concentration in the original source rock. So again the same formula will be used. Okay, so let's move with the next question. What happened? Okay, so another question is grade of iron in an ore body which having the 80 weight percent of hematite and 20 weight percent of gangue material. So we have to find out the grade of iron. Here I have already written the answer, but let us see how to calculate or how to deal with such questions. In the other exams, they are asked and they can be asked uh, copper in place of iron. They can ask about the chalcopyrite. They can ask in different minerals based on such concepts. Okay, so now first we will calculate the molecular weight of hematite. So molecular weight of hematite, Hema. Okay, so this is the molecular weight of hematite. So we know the formula is Fe2O3. Okay, so based on this formula we can calculate the atomic weight of iron is given, atomic weight of oxygen is given. So it will be 55.85 into 2, because we have 2 iron in the formula, plus the atomic weight of oxygen, that is 16, into 3, because we have the 3 atoms of oxygen. So it will be around 159.7 Okay, then we will calculate the molecular weight of iron in the molecular weight of iron in the hematite. So let us see molecular weight of iron. So we know that there are two atoms of iron, so it is simply 55.85 into 2, and that will be 111.7. Okay, so this will be molecular weight of iron. Now let us assume that we have a total ore of 100 gram. Okay, so if we have the total weight is 100 gram. Now if total weight is 100 gram, then the weight of hematite, that is 80%. So weight of, where is my color? So hematite will be 80 gram, and in this much of hematite we have this much of iron. So we can calculate in 80 gram of hematite what will be the amount of iron. So that will be 55.95. Okay, 50 55.95. Okay, and hence this will be your answer. Okay, so in 100 gram of ore body you have 55.95% of iron ore. Okay, so I hope you get this point. You can calculate this 80 gram from a general mathematical calculation, that 159.7 gram of hematite have 111.7 gram of iron. Then 1 gram of hematite will have 11.7 divided by 159. Then 80 gram of hematite have into 80. Okay, so this is the general mathematical, so you can calculate this like this. Let us see another question. Okay, so it is about the uh, theory of isostasy. So there are two theories, Airy's hypothesis and Pratt hypothesis. This is asking about the Pratt's hypothesis. So what is given? The density here it is 28,000 kilogram per cubic meter, and the height, that is 28 kilogram. And this crystal block, you have to find out the density of this, while the extra height is 4 kilometer. So how you can calculate? This is the one of the easiest numerical which is asked, and asked in many exams. You know that this is the depth of compensation, and at the depth of compensation the pressure is equal. So whatever pressure exerted by this block will be equal to this block, and we know that formula of pressure is rho gh. Okay, so let us calculate this one. Rho, your density is 2800. G is gravity, let us put it as same, and h, height, is your 28 kilometer. 28 is equal to pressure exerted by this block. So here we have to find out the density, that is rho. G is gravity, which is will be same, and the height is now 28 plus 4. Okay, this total height is 28 plus 4, or is equal to the 32 kilometer. So G will be cancelled, and by solving this equation you will get rho is equal to 2450, which is written. Okay, this is simple question. This question many times asked, in sometimes in one number, sometimes in two numbers. So important, easy, and frequently asked. Let us see next question. Next is based on the RQD, that is rock quality designation. Here you have very simple formula. RQD is equal to length of course which is more than or is equal to 10 mm, okay, sorry, 100 mm divided by the total length. Okay, now what is this? Let us see. We are having a borehole of 10 meter. Okay, so first you will get some clay material, then you got a core of 10 centimeter, then you got a core of, let's say, 12 centimeter, then you got again the rock samples, small pieces of rocks, then you got a core sample of 8 centimeter. Okay, so this one and this one is more than 100 mm. Okay, so we will add these two, so that will become 12 divided by the total length was your 10 meter, so divided by 10, and we will convert this meter into centimeter to make the unit similar, so multiply it by 100. This is the formula, this is the concept which we are using here, and same it is given in the question. The drilling was carried up to a depth of 20 meter, so total length will be 20 meter. Let us write here 20 meter, or let us convert into the centimeters. Okay, so this, okay, then each over 100 meter the material which is more than 100 mm is added to 16 meter. That means we are adding the materials which are having the thickness more than 100 meter, so it is 16 meter. 16, now both are in the same unit, so we can neglect this. Okay, into 100, now solve it, 25, and you will get answer is 80%. So this is the simple RQD question, and it asked some 2-3 times, and it is quite possible to be asked in the this paper also. Okay, one more thing is RQD can be calculated by one more formula. Let me, okay, so sometimes one formula is RQD is equal to 115 minus 3.3 JV. Okay, so this formula is also used for calculation of RQD. So one question is asked based on this formula. So here JV is the number of joints present per unit volume of rock. So they can be asked a question like this. We have a 3 cubic meter of rock block having the 20 joint sets, 20 number of joints. So simply you will divide and make it unit volume. So in the unit volume we will have the 20 by 3 number of joint volume ZJV. So we will put this value and calculate the RQD. Okay, so this can be asked. Now let us see next question. Shear wave velocity in an igneous rock with a density of 2.7 gram per cc and rigidity modulus of 24.3 gram 24.3 gigapascal, and we have to find out in the kilometer per second. So simply what we will do, formula of velocity of shear wave or velocity of secondary wave is equal to under root mu divided by rho. So we know the mu, but we have to change it from gigapascal to the pascal, and density, you know that this is the density. Okay, okay, so we have to convert unit of density also, because here it is centimeters and here it is in kilometer. Okay, so changes should be done. Okay, this is the formula, and yes, they can also ask you about the velocity of primary waves. So velocity of primary wave has the formula of 4 by 3 k plus mu upon rho. Okay, so this is the formula for primary waves. Now let us see another question. The value of EH corresponding to the upper limit of natural surface aqueous environment at pH of 8 is. So this is asked only once, but since they asked about the upper limit, so this is quite possible that in this exam they will ask you about the lower limit. So here is the formula for the EH of upper limit. Okay, so for upper limit the formula is 1.23 minus 0.059 into pH. Okay, where is my cursor? Okay, and formula for lower limit EH, now it's time for lower limit. It is a 1.2, sorry, 1.23, not only minus 0.059 pH. Okay, so they can ask lower limit in this time. Now let us begin another question. Here it is asking a basaltic magma has initial nickel concentration of 300 ppm. Now olivine crystallizes from this magma by equilibrium crystallization case 1 or frictional crystallization case 2. Then the absolute value of difference between the nickel concentration of liquids resuming after 25% crystallization in these two cases. Okay, so as I have told you about the in the I think first question about the batch melting. So this is a kind of similar condition. Let us solve for the case 1. Okay, so for the case 1, the for both cases I think the crystallization is 25%, means the value of F will be 25 divided by 100, or it will be 0.25. Okay, but sorry, this is not 25% crystallization, that means the remaining melt is 75. Okay, so the value will be 0.75. The value of F is there. The initial concentration is 300 ppm. Okay, 300 ppm. So simply we will use the formula for case 1, that is Cl to Co is equal to 1 upon Di 1 minus F plus F, and for the case 2 Cl to Co is equal to F to the power Di minus 1. Di minus 1. Okay, what will be the Di? It is given in the question. It is 10. Okay, so we can calculate for both, and then I think what they are asking, the differences. Okay, so whatever value we will get of for Cl, we will differentiate those and we will find the difference. So this is the question asked, and this type of question can be asked in this exam also. Let's move to the next question. The geometrical factor for following electrode configuration. So electrode configuration, there are questions asked in different previous year papers. The basic fundamental formula for this is the apparent resistivity, that is rho is equal to rho is equal to del V. V stands for the voltage divided by I, or the current, into K. Okay, this K is your geometrical factor. Okay, and for the formula of K is equal to 2 pi divided by 1 upon P1 P2, the distance between these two, which is A. Let me write the formula first. P1 P2, okay, plus the distance between C1 C2, 1 upon C1 C2, then minus C1 C1 P2, C1 P2 minus C2 P1. Okay, so this is the formula. So now you can calculate by putting the values. Okay, so this is also important question. Sometimes they may ask the apparent resistivity, they may ask you about the voltage difference, they may about the current which is passing, or they may ask about the geometrical factor. Now one thing you can also add in this, that arrays. There are two type of specific arrays which are asked in exams. One is the Venner array. So what is in the Venner array? P1, P2, C1, C2, they are at the same distance, like this. Okay, so distance A, B, C, all of these three distances are same. So this is for Venner array. Such as you have a Schlumberger array. What is there? We have a configuration something like this. So there is a distance and there is another distance. Okay, so and these are the current electrodes, these are the potential electrode. Here also these are the current electrodes, and in the middle we have the two potential electrodes. Okay, so this is for this questions or such type of questions. Now it's all about for today. I hope you liked the video. Share it with your friends, and I hope I will make some more videos for such numerical questions which are asked in exams, and there is possibility uh, with the similar questions to be asked in this 2022 exams also. So thank you so much.